Howdy ho kids, Mrs. Broderick here. Today I'm going to tell you about this man, Charles Darwin, also known as the father of evolution and natural selection. So I added this PowerPoint on, but I'm going to go through it with you so you can go through it too. Charles Darwin was actually born on the same day as Abe Lincoln, February 12th, 1809. And he was born, he was the fifth out of 6 kids. His parents were actually quite wealthy. And his father was a doctor and his mother was she was just a housewife, I think. But she died really early. And Charles ended up really becoming independent and helping with his family. But they were very, very religious. He went to Edinburgh to study medicine, but he hated it. I mean, guys, you have to think about this. Like, back in the 1800s, when they would go and, like, do surgery, you hoped that they would give you alcohol so you just pass out. They would sometimes just hold people down and cut off their limbs. He hated this. He said, this is ridiculous. He's like, I'm not going to do this. So he went back to school, and he went to Christ College in Cambridge. And he was actually studying theology. And I don't know if you guys know what theology is, but that's faith. And that's studying, God's creation, essentially. He ended up in 1831 going on this journey on the HMS Beagle. And this journey took him all over the world. And he wasn't real sure if he wanted to be a priest, and he wasn't real sure if he wanted to be a doctor. So sometimes you just gotta get out of your comfort space and you need to go do something. So he traveled the world, and he actually went in. He was known as an unpaid gentleman's, an unpaid gentleman's companion, AKA intern. And he didn't get paid, but he got to travel the world and see all kinds of things and see what he liked. Now let me tell you this: when he was a kid, he used to collect things. He was a big collector. He loved collecting things. And he collected every beetle in England and had them in a little box. And he kept them all. So he was an observer. He was a collector. He liked all these things. And while he was on his journey, he actually collected things. We're going to talk about it. This 2-year journey ended up being 5 years. And he didn't get back to to England until 1836. This is the boat he went on, the HMS Beagle. HMS stands for Her Majesty's Ship. It contained 74 people, and it was only about 90 feet long, which is like the length of one of our hallways at school. And it was only 24 feet wide, which is like the width of like my science room. Okay? For 5 years. Nuts. When he got back, he did in 1839, he married his first cousin. I know, that's so creepy and not something we really look at nowadays, but back then it was kind of common to kind of keep your, what they would say, blood pure, and you would keep your family in your line. And he had 10 kids with her. But after his journey, he started really looking, and he started noticing that, there was something real weird about all these adaptations that animals were having, and that they were interesting to him. So he started coming up with this theory of evolution by natural selection. You're naturally selected to live in an area. You have adaptations that make you survive really well and beneficial for your existence. So in 1839, he published The Voyage of the Beagle, which is his voyage around the world on this ship. And in 1859, he came up with his well-known book on the origin of species by means of natural selection. And actually, it is still published today, and his theory is nearly 160 years old. So it's a theory, it's not a law, because nobody could actually stay there and watch evolution occur, because it occurs over a very long period of time. But you can go and look at animals and do comparative anatomy and say, oh, well, we were related to them, and here's how things are changing. Here's his voyage. So I normally go into a really big thing about this, but I won't. He started off here in England, He went from England down to South America, and you have to understand that he had never seen pythons or toucans or parrots, all these crazy animals, and he was interested, so he started collecting them along his way. He went down to the tip of South America and Chile, and he described in his book on the Voyage of the Beagle of sitting on the beach and being accompanied by a lot of fat little men in tuxedos. Do you know what those are? Penguins. He had never seen a penguin before. They came up and they were in South America, got supplies, and then went over to this teeny little island. It's a speck. It's nothing. It's the Galapagos. And there, the things he saw are what we're going to mainly talk about. Now, understand this is a globe. So if I go over here, it actually brings me up over here. He went and he stopped in New Zealand. And in New Zealand, he saw Komodo dragons, which scared him half to death because he had never seen anything like that. He went to Australia where he saw babies in pockets of their mothers, like kangaroos and all those marsupials. He went to Africa, and of course, he saw many, many different things there. Painted horses, long-necked horses, giraffes. And he saw all these things and was so curious of, well, if giraffes live in Africa, why don't they live in England? Why don't they live in Australia? What's kind of going on here? Now, I have to tell you, this entire time he was taking dead animals, boxing them up, and sending them to Emma Wedgwood in England. Nothing, like, he could have just sent her a love letter, but he was sending boxes of dead animals. It doesn't sound very interesting, does it? Anywho, she kept them all for him, and she stored them aside. He got back to England, didn't think much about it, and then he started really going through and looking at them. And he started to think, wow, I went to all these different places and I saw all these different things, and why are they so different? The biggest part of of his journey was obviously the Galapagos. And if you could look at the Galapagos, it's about 600 miles away from South America, which is kind of like driving from Pittsburgh to Ocean City and back, or from Pittsburgh to like down to Florida. And the big thing about the Galapagos is that it is geographically isolated. It actually has no big predators on the island. So animals could get to enormous sizes and they could reproduce and their babies could survive. This is what the Galapagos look like. They're all named after Spanish explorers because those are the first to be there. There's, San Salvador, there's Santa Fe, Santa Cruz, the Pinta, Española. Española is a really cool one. But they were named because of the explorers that got there. They were the ones that named it. The main island looks like a seahorse, doesn't it? So if you ever get to see that, it looks like a seahorse. Now, when he got to the islands, he was told by a chieftain that any island you're on is going to have its own specific type of tortoise. And he went, what? There are 3 giant tortoises that live in the Galapagos. We have what's known as the saddlebacks. I know my drawings are great. I know you miss my drawings, kids, I know. The intermediate and the dome-shaped. This, my friends, is a saddleback tortoise. And a saddleback tortoise, if you look at it, is found to be living in areas that are very arid and that the vegetation grows real high. So they found that on the islands that they were at where the vegetation was really high, they had tortoises that had the saddleback, because it looks like a saddle of a horse, and that their long necks enabled them to get the plants at the top. Now, if you were a tortoise that had a short neck on that island, could you survive? Could you get enough food to be able to reproduce or to have children or to live? No. So all the animals are really well adapted to the islands that they're on. These have a raised back. They have pretty long legs. And if you look, they're kind of camouflaged to the color of their surroundings as well. These are the smallest overall. They can weigh anywhere from like 200 to 250 pounds, including shell. And let's remember, my tortoise in my classroom may weigh like a quarter pound. So this is huge, okay? This is its buddy. I don't know if you can see that. This one's been eating way too many Twinkies. This is the intermediate. And if you look at the shell, if we go back and forth, if you look at the shell, see the shell's up real high here. The intermediate, the shell comes down a little farther. So the necks can't reach as high. The intermediate tortoises are found on islands where vegetation is kind of like at the mid-level and that there's lots of it for it to eat. And it is the second biggest in the family. It can weigh, you know, like anywhere from like 225 to 275, or I'm sure this guy right here has been eating Twinkies. He's been eating too much. But their reach is right in the middle. That's why they're called intermediate. And then there's this dude. He is the dome-shaped. Look how far down his shell comes. He's essentially a walking lawnmower. He eats everything off of the ground. If he was on an island where the saddlebacks are, he would never be able to survive because his shell limits his vertical reach with his neck to be able to eat. Therefore, he would die and wouldn't be able to live on that island. So the chieftain was right. These animals were living on the islands that they were really well adapted to and the islands that they were doing well at. And these are the biggest. I think they can be up to 300, if not more than that. So they're pretty big guys. Now I want you to think of something. I want you to think of things that we have inside of our bodies that are adaptations. So if we think real quickly, we can think of our teeth. Remember we talked about our teeth? We have herbivore teeth and carnivore teeth, which makes us omnivores with both, which means we can eat both types of food. We also have tonsils. We don't need those to survive. These things are known as vestigial structures. So we have our tonsils, our wisdom teeth. You don't need those to survive. They actually get rid of them most of the time. You have a tailbone, which means we used to have a tail. We have an appendix, which was actually a very small stomach that used to go and help us digest when we were eating a lot of grasses. It would give us extra bowel to digest the food that we were eating. And it's actually toxic to us now. So sometimes people get an appendicitis and have to have it removed. We have gallbladders. I mean, there's all kinds of things we have inside of our bodies that we don't need. These are vestigial structures. And these are all things that prove to us that at one point, maybe we weren't always this way. Maybe we were different. And we're slowly evolving to change. Wisdom teeth are actually starting to go away. My dad didn't have his wisdom teeth. We're having smaller jaws, which don't enable us to have that extra set of teeth. The extra set of teeth would have been beneficial if whenever we were living and we were hunters and gatherers, we would lose our teeth. I mean, there's no toothpaste or, dental floss. So the teeth would go lost. When you hit like 15, 16, the teeth came back in, which enabled you to go and grind down your food to be able to eat. I want you to think about those vestigial structures. Some other things he saw on this island were iguanas. And we're talking big iguanas. They were over 1 meter long. That frightens me. I don't really like little things that scurry on the ground, but this was 1 meter long. They were big. And he found there were 2 types. And they lived right next to each other. There was a land iguana. Like this, you can see he has his camouflaging helps him blend in with the rocks here. He also has really sharp little feet, like little track spikes to run through the coral that he lives on, and he only lived on the land. This is his cousin. This is the marine iguana. Now, the first thing you notice is it has a darker skin. It's in the oceans. The oceans are cold. This dark iguana can then absorb the sunlight, which would then enable it to stay in the water for long periods of time. Its teeth are even different than its land iguana cousin, and its feet, its claws, if you can look at those claws, are really long and sharp, so it can hang onto coral. It is a vegetarian. These 2 are cousins. They're not the same species. They live right near each other, but one lives in the water and one lives on land. They somewhere split and evolved away in a different branch of their trees. And these animals have really cool aspects. Go through the slide, read all the different things that you see about them. They're really neat. I put some cool data in there. The last thing Darwin did notice, and this is after he got home, was the finches. These are all a finch, which is a type of bird. But the one thing different is all their beaks are different. All their beaks have actually been adapted to wherever they're living. So I drew them up there. So whatever island they're on, if they're on an island that only has big seeds, this guy's going to live there. If they live on an island where there's little seeds, maybe this guy lives there. If there's an island with big seeds, are we going to see this one? No, he can't crack the seeds and eat them. So he's not going to be able to survive. He's not going to be able to live there, reproduce. He's going to move on to another area. So Darwin found out that all the bird species, remember he sent him all those birds to like his girlfriend, oh my God. He found that those beaks all had a beneficial adaptation, and that it's called adaptive radiation. They all could only survive if their food supply is there. Some of them went and ate leaves, some of them ate insects, some ate seeds, some actually used their beaks to use as tools, some ate grubs, they have like a little grub hook on the front of them, and then some ate fruits and berries. These finches could all live on the same area only if they had the food supply that's there. If not, they have to move on somewhere else. And if they move on somewhere else, they may even adapt more. They might get bigger, they might get smaller, they might get extra wings or different colors on their wings. So it's pretty interesting. I'm trying to flip through. You can read all these things. And this is called a phylogenetic tree. A phylogenetic tree shows you how closely related things are. It shows that separation where one species, not that it wakes up one day and says, hey, I'm going to change. It just is born different. But that difference enables them to be able to survive. That doesn't mean that this guy goes away. That guy can still live as long as it has its food too. They're kind of like cousins. So we may think of us and chimpanzees. We're really closely related. We have really similar DNA, but we look really different, don't we? Chimpanzees don't speak, we do. They can grunt and make things, they can do things like that, but you know, they're kind of different. Chimpanzees use their hands. I mean, they have a lot of the same things we do. They even, you know, they can't walk bipedally like us for a long period of time, but you know, they do go through that motion. That is, oh, well, this is kind of cool. Do you want me to explain it to you? It's in your book, but this is Glyptodon. You guys see this? This Glyptodon lived millions of years ago, and its closest relative today is actually the armadillo. And if you look at my PowerPoint, you'll see that they have a lot of things in common. They both have armor on their backs. They both have short ears. They both have these kind of snouts that go into the ground. They have claws to dig it in the ground. This was a insect eater or vegetarian. The big problem with Glyptodon, why he didn't survive, is he was huge. This is a picture of a human. He was almost 6 feet tall. So Glyptodons were big but slow. If you're big and slow, guess who's going to eat you? The carnivores. So Glyptodon went extinct, which is another word. This is when something goes away, but it doesn't mean that they actually are all gone. It just means maybe they changed into something else. Glyptodons, if you think about them, were real big and they were slow. But if all the Glyptodons are there, the cats or the big animals are going to eat all the big Glyptodons. The little Glyptodons are going to be the ones that get away. And if they get away, they can reproduce. But then all their babies are going to be little. So they just actually kept on breeding into smaller species. So the Glyptodon we know of is now, the closest relative is the armadillo. And it's very small. Armadillos are just, you know, little balls there. And they, and you can see that it's kind of related. Read it in your book, it's great. You know, we could think about bears again, like polar bears and black bears, and who's more fit to live where? Well, it depends on the season, right? If it's winter, polar bears are going to live better in the winter. There's some things that make them much better at living. Polar bears can camouflage into the snow. You can see that they have large feet, which help distribute their weight so they don't crack through the ice. They're actually really good swimmers. They can hold their breath up to like 2 or 3 minutes, probably even more than that. I don't know. I haven't Googled everything. They have 4 inches of blubber on their bellies, which help them stay warm in those freezing cold temperatures. And under their fur, they have black skin, and that their fur is hollow, which actually holds on to air. Their body heat heats up that air around them, and they're actually constantly warm. They are really well adapted to live in their environments. I mean, I could talk to you about why they're going away, and I don't want to because it makes me sad. We sometimes get to the point where we think, well, it's just animals that are evolving, but actually plants evolved too. Cactus has evolved. Cactus is really what we call fit to live in warm, low moisture areas. And it is normally going to be in the deserts. So if we look at a cactus, you can see this is known as a succulent plant, which means it holds on to water. And that a cactus has evolved over the years. Its leaves are actually the spines, the prickles, the things you may get stuck in your finger, the spikes. And those collect and photosynthesize, C6H12O6. And it actually also protects them from herbivores. And they have this waxy coating. Remember we talked about a cuticle before when we talked about plants? They have a cuticle on the outside of their stems, which enables them to hold in the moisture so it doesn't go and evaporate out and the plant would die. So they're really well adapted to live in the desert. They may not do so well here in Pittsburgh where we get so much rain, but they're really well adapted to live in like Arizona. Venus flytraps are another really cool plant. It's a plant, but it eats flies. And we've talked about Venus flytraps. They eat the flies to get the nitrogen that they don't get in the ground in the areas that they live. They've adapted to live in these areas so that they're surviving, they're moving on. They found that niche that they may not be able to survive other places because they'd be in competition with other plants and they're wee little, but they're really good at living in areas where other plants can't be, where there's no nitrogen. So yeah, they're really neat. Oh, interesting facts. You guys can go look at this. So a study was done about moths, and they found that there's two types. There is a peppered moth, and it can be white or it can be black. And during the Industrial Revolution, the bark on the trees were noticeably black from all the soot in the pollution. In those years, the black moths' numbers were high. They were camouflaged, they were surviving. No birds could pick them off and find them. But the white moths during the Industrial Revolution, their populations were really low because look, they stuck out like a sore thumb on that. So they've now found that now we're cleaning our air. Tree bark is actually getting lighter. They found that the dark peppered moth populations are now low and that the light moth populations are now high. And that's because of camouflage. The white moth can now camouflage, the dark moth cannot. This is evolution. This is how something can survive and move on into the next generation and have birth to babies that are going to be like them and survive as well as they did. If you weren't surviving well, you're not going to do well. You're not going to be able to have babies and move into the next generation. You're going to be phased out. So that's pretty interesting. Now, human evolution is the last thing I'm going to talk about. And in human evolution, we're really related. Remember I told you to chimpanzees. This is our This is our phylogenetic tree. You can see here's humans. We're really closely related to chimpanzees, and then gorillas, and then orangutans and gibbons. But if you look right next to us is chimpanzees, and here's where we split off. That's when we all became cousins. And we're known as a great ape. We are Homo sapien, and our family is ape. And our family is actually hominid, but we are part of this great ape family. Some things that will go and help prove this to you is looking at the anatomy of Lucy. Lucy is so cool. Lucy was found in Africa by Donald Johanson and Tom Gray in 1974. She was actually in, Hadar, Ethiopia, which is in Africa. And they went and they carbon dated her bones to 3.2 million years old. She's old. And they didn't get all of her skeleton, so her fossils, not everything preserved, but a majority of it did. She has less ribs than us. You can see less vertebrae in her back. But the most awesome thing about her is that her femur and her tibia were shown, which showed that she was bipedal, which means she walked on two legs. This is the first fossil record we have of one of our cousins that we've evolved from that's walking upright, not knuckle walking like a gorilla. It's standing up and walking. Standing up and walking enables you to, one, get away from your prey faster, two, makes you able to, if you're always constantly on your knuckles, you're not able to hold things. So now you can walk and hold things, or climb, or hold your baby, or gather things. So she was the first bipedal, and they found by her arm length that she was probably a tree dweller, which means that she would climb into the trees and stay there. Also think about Africa. Think about the savanna grass. If you're a knuckle walker and you're in the savanna grass, can you see a predator coming at you? No, you're sitting prey. They're just gonna eat you. If you can stand up in your bipedal, you can look over the grass and you can actually see something coming at you, which means you have more time to get away. And if you get away, then you're going to be able to reproduce. And if you're able to reproduce, then you're able to pass on your genes to the next generation. Natural selection. So we know she was a girl by her pelvis. She was probably 3'6", and they're estimating her to be at like 62 pounds. So she was much smaller than we are. But her arms were also shorter, which then shows that she wasn't such a knuckle walker. Our arms are shorter than chimpanzees or gorillas or orangutans because they still walk on all fours. But she was pretty cool. This is another thing. This is fossilized again. This is rock. And in this fossilization, this was found in Africa again. They carbon dated it back to about 3.5 million years ago. And here it was in Tanzania. If you look, you see these large strides on the one side, right? And you can see there's no knuckles. 3.5 million years ago, there was something walking on 2 feet. And you know what else is really cool about this picture? Can you guys see the footprints on the other side? They're little. That means that there was probably something much smaller walking next to them. They were taking care of their babies. They were more vested in their family. They were holding on and making sure that their offspring got into the next generation and was healthy. If we look at their foot in the mud, it showed that our weight was mainly on the weight was mainly on the toe on these fossils. Instead of it being like our knuckle walker cousins along the outside, it would have given a moon shape. This was more like walking in the sand. Bipedalism is huge for us in our existence. It's enabled us to be able to get away. It also has broken us on our cousins. Our chimpanzee cousins stayed one way. We kind of went another because we could walk upright and we could walk on 2 legs. This is the fossil record of humans. And if you guys get a chance, I think it would be awesome for you to go and look at all the different types of human-like species that are out there. They don't exist anymore. We are, if you look at us, here's us. Here's Homo sapien right here. And the only one who was close and living on the planet at the same time our species was living here was Neanderthal. And sometimes you guys call them caveman. They had like a big brow bone. They had a large chest. You can go look up some pretty interesting stuff on them too, of why they maybe died out, or why they're not here anymore. But all of this is showing us that certain species are here today because they are naturally selected. They have adapted to their surroundings. They're able to be here. They are very well at surviving and being able to reproduce in the next generation. If an animal can't survive or can't adapt or can't cut it, it goes extinct. And many animals, more animals on this planet have gone extinct than actually have ever lived on the planet. We only have about 1% of the species that have ever lived on this planet currently on Earth. Most things have already died and hopefully become fossilized so we can find them, but they've gone and are no longer with us. And a cousin may be here, an adaptation from that species, a subspecies is here. So I really, really, really hope that this may have helped you guys in some way. It's long, I'm sorry, I didn't mean to make it so long, but I just get carried away, so it just happens. If you guys have any questions, you are more than welcome to go ahead and email me, send me any questions that you have, or Mr. Sott or Miss Sidecheck, and please, I hope this helped you on your questions and on understanding natural selection. I miss you all, can't wait to see you guys again, maybe someday, and stay safe, okay? Bye.